For this project, we used the DJI Phantom 3. This drone supports point of interest features and hosts an FTP server on a self-generated hotspot to wirelessly access files. We interface with the drone through a mobile phone application called DJI Go. Through this application, we can utilize the point of interest features and control the drone in flight. For our central server, we used a Linux-based machine. We use a laptop capable of connecting to wireless networks. Our software was also built with the Linux operating system in mind. Our software should ultimately be portable enough to transfer and use on any other Debian or Ubuntu Linux machine. And the final piece of hardware was an iPad and a hologram pyramid. We use an iPad and an acrylic pyramid to represent our 3D renders as a hologram to more accurately represent our objects in three-dimensional space. For our network communication, we developed a central server application that could monitor an FTP server hosted on the drone controller. This central server monitors for file usage and size by acting as a watchdog for any file within the drone. Once video footage is completed, the central server automatically downloads the footage and initiates the 3D rendering. Our central server is multi-threaded to host multiple video renders simultaneously. Each thread takes footage downloaded from the previous phase and undergoes a few steps to procedurally generate 3D renders from the footage. First, we utilize a command line tool called FFmpeg to generate photos from our video capture. After generating the photos, we run our photos through a SIFT algorithm, or Scale Invariant Feature Transform, to detect local features in our images. Originally conceived by University of Washington's Dr. Chang Wu, this analysis determines depth, scale, and orientation based on the relational positions between the local features or points between each image. The SIFT analysis generates a sparse reconstruction of our object. We then run this sparse reconstruction under a CMVS analysis, or a clustering views for multi-stereo analysis, originally created by Yasutaka Furuwaka and Dr. Jean Ponce from the University of Illinois. This algorithm attempts to construct a three-dimensional image based on the vector and positional information generated by the SIFT algorithm. In other words, it takes the sparse reconstruction and estimates the orientation of each point on a three-dimensional plane using its relational movement data. The result of this analysis is the actual point cloud, named the dense reconstruction, which can be viewed with most CAD softwares.